In this video, we are going to be discussing rationalizing the denominator when the denominator is a binomial. This video, we are going to be talking about rationalizing when we have a binomial in the denominator. So this is going to be a little bit different than the previous video where we just had a monomial, because we cannot just multiply by whatever radical we see in the denominator over itself. Because if we try to do that, as you can see, if I try to multiply this entire thing by the square root of 3 over the square root of 3, I'm going to need to distribute this square root of 3 not only to the square root of 3, but to this 2. So that means I end up still having a 2 root 3 in the denominator, which does not bring me any closer to the answer I'm looking for. So this time around, to be able to get rid of the square root, we need to multiply by the conjugate pair of the denominator. So a conjugate pair is the exact same terms. So we still have a 2 and the square root of 3, just our sign in the middle changes. So that means since we have a minus sign, that means what I'm going to actually multiply by is a 2 plus the square root of 3. So the reason why I'm doing this is because if you think about your distribution, I'm going to have two terms that are both going to be the positive and the negative of my square roots that are left, so they are going to cancel one another out. So again, I need to be multiplying by 1, so I'm going to be multiplying by 2 plus the square root of 3 over 2 plus the square root of 3, because I do not want to actually change the expression. So the nice thing about this foiling of your denominator, again, since I'm multiplying by conjugate pairs, I don't have to actually do the O and the I of FOIL. I just have to multiply my firsts together and multiply my lasts together, and then simplify, because my outer and my inner piece are going to give me those exact same terms, just one positive and one negative. If you don't believe me, you can work it out and see for yourself. So let's go ahead and simplify this numerator first. So that means I'm going to be distributing this 2 to this binomial. And if you notice, I put parentheses around any binomial that's going to be in either a numerator or a denominator, because it helps me, and will actually help you as well, see when you need to do any kind of distribution. So immediately in that problem, the very first thing you saw me do was put parentheses around my denominator. So get into the habit of, you see a binomial or something larger in a numerator or denominator, put that thing in parentheses. And that way you actually will make a lot fewer mistakes. So my new numerator is going to become 4 plus 2 root 3. And my denominator, again, because they're conjugate pairs, I only need to go and multiply my firsts together. So I need to multiply this 2 times this 2. And then I need to multiply the lasts, so the negative root 3 and the positive root 3. So 2 times 2 gives me 4. Negative root 3 times positive root 3 gives me a negative 3. So then we can simplify this. Well, 4 minus 3 is just 1. So this is 4 plus 2 root 3 over 1. But again, anything divided by 1 is itself. So I'm done at this point. So this is my final answer. I don't have anything left in the denominator, which was kind of nice. So again, we're going to be working with conjugate pairs. You've used conjugate pairs in previous maths, because again, this is especially when you're thinking about factoring and stuff like that, you've used conjugate pairs. So now let's try the next one. So we have 5 minus root 6 all over 2 plus the square root of 2. So again, the very first thing I'm going to do is I'm going to come in here and I'm going to put parentheses around any binomial or anything higher. So I'm putting it around my numerator and my denominator. Since I'm trying to rationalize my denominator, that means I'm going to multiply this binomial by its conjugate pair. And this conjugate pair is going to be 2 minus the square root of 2. So all I'm doing is just changing the signs. Again, to make this complete, I need to, whatever I multiplied in the denominator, I need to do it in the numerator, because again, that is 1, and if you multiply anything by 1, it's still the exact same thing. So that's a question you should always be asking yourself in math. Did I multiply by the right thing? Am I making this a 0 or am I making this a 1? Because you don't want to actually change the problem. So we can start and we can multiply our numerator. So again, I'm going to need to distribute this 5 to both terms and then this square or negative square root of 6 to both terms. So this will give me 10 minus 5 root 2 minus 2 root 6 plus the square root of 12, and the square root of 12 is just going to be 2 root 3. So there's nothing I can add together. There's no like terms in my numerator, so that's going to stay exactly like it is. I know it's ugly, but it is what it is. So in my denominator, so now I'm going to be distributing, but I only need to do, again, since they're conjugate pairs, multiply the first, and then multiply the last, and then simplify. So 2 times 2, again, gives me 4. And the square root of 2 times the negative square root of 2 gives me a negative 2. So our final answer is just going to be 10 minus 5 root 2 minus 2 root 6 plus 2 root 3 all over 2. So the one thing that you need to just make sure of is that if this 5 had been some kind of even number instead, I would have needed to simplify this a little bit further. But again, since this is a 2, that's why I said an even number. But every single term in my numerator was not divisible by 2, so I'm done with that simplification. So I have 2 problems for you to try. You have the square root of 3 over 2 minus root 3, and you have 2 plus root 6 all over the quantity 3 minus root 5. So again, pause this video and work these out. Come back and check your answer. All right, so you should have gotten 2 root 3 plus 3 for the first one, and then the second one, 6 plus 2 root 5 plus 3 root 6 plus root 30 all over 4. So if you did not get those, just look back, try to see where your mistake was, go line by line until you found your mistake. And again, just keep on practicing.